Hi everyone, so in this video we will study about OpAmp in positive feedback. OpAmp in negative feedback is also very important, but that is on easier side. I hope everyone is comfortable with OpAmp in negative feedback. So OpAmp in positive feedback, that is one of the topic where students struggle. So that's why we are studying this particular topic. After this video you will be very comfortable with OpAmp in positive feedback as well. Secondly, when you are watching this video, you need to have a basic idea of OpAmp. At least basics of OpAmp you should be clear. Otherwise, you will not be able to understand this particular video. So if you are someone who has completely dropped OpAmp, if you are someone who has completely dropped analog electronics, then you should not be watching this particular video. But if you have the basic idea of OpAmp, you can certainly watch it, and there is very high chance that 2 mark of question can come from this particular topic. Okay. So let's start with the question. We will go to OpAmp later on, but first let's build up the concept. So what is there in this question? That there is a circuit, you are applying an input, you are getting some output there. On this circuit, you are applying some input, getting some output. What is there inside the circuit that you don't know? What is there inside the circuit that you don't know? Voltage transfer characteristics for the circuit is shown. That what is the relation between V0 and Vin? That relation is shown here. Here there are two characteristics. When we study diode, we also draw the transfer characteristics, right? In diode, like let's just say if Vin is greater than 0.7 volt, then this is how the graph is going. If Vin less than 0.7 volt, then this is how the graph will go. If Vin is between minus 0.7 to plus 0.7, then output will be 0. So these kind of characteristics we have drawn, but there was only one characteristics, right? There was only one characteristics between V0 and Vin. Now you are getting two characteristics between V0 and Vin. Okay, so we need to study these two characteristics. How we will study it, I'm gonna tell you about that. Okay, firstly we need to understand how to study these kind of characteristics. So first you need, and what is the meaning of this arrow, that also I will tell. So just hold on to the video, just see the concept now. So what they are saying, find V0 if Vin is equals to 3 volt. So where will be 3 volt? In this graph the 3 volt will be somewhere here, and in this graph 3 volt will be somewhere here. So what is the output when Vin is equals to 3 volt? So this graph is saying that output should be 1 volt, and this graph is saying that the output should be 1 volt. So both graphs are saying that when Vin is equals to 3 volt, output should be 1 volt. So yes, output is 1 volt. Now Vin is equals to minus 2 volt. Where will be minus 2 volt? Minus 2 volt in this graph will be somewhere here. So this graph is saying that output should be minus 1. Where will be minus 2 volt in this graph? In this graph, minus 2 volt in this graph will be somewhere here. And this graph is saying that output should be minus 1 volt. So yes, output will be minus 1 volt. There is no doubt about that. But what about this one? When Vin is equals to 0.5 volt. Vin equals to 0.5. Where will be 0.5? Here it will be 0.5. What this graph is saying, the output should be minus 1 volt. And what this graph is saying, on this graph, where will be 0.5 volt? Here will be 0.5 volt. What this graph is saying, output should be plus 1 volt. This graph at 0.5 volt is saying that output can be minus 1 volt, and this graph is saying that it should be plus 1 volt. So who we should listen to? So that's the point now. In between, here, in between, where the graph is changing, 2 volt. This graph is changing at 2 volt, and this graph is changing at minus 1 volt. So between minus 1 volt to 2 volt, both graphs will say different thing. Let's just say if my Vin is 0 volt, this graph will say that output should be plus 1 volt. This graph will say that output should be minus 1 volt. Let's just say my Vin is 1 volt. If my Vin is 1 volt, this graph will say that output should be minus 1 volt. This graph will say that output should be plus 1 volt. So who we should listen to? So that is the point here. Now this arrow thing will come into action. So what will be the answer for this one? You will say insufficient information. Insufficient information. So how the question should have been framed? The question should have been framed in this manner, that if my Vin is increasing from minus infinity to infinity, here in place of minus infinity to infinity, they could have written anything. The important point is your Vin is increasing. Your Vin is increasing. So if your Vin is increasing from minus infinity to plus infinity, that means this arrow is showing that Vin is increasing, no? That means you are going into the increasing direction of Vin. This will be the increasing direction of Vin, no? And what will be the decreasing direction of Vin? This will be the decreasing direction of Vin. That means you are working from plus infinity to minus infinity. And here you are working from minus infinity to plus infinity. So what they are saying now, if your Vin is if Vin increases from minus infinity to plus infinity, then find V0 at Vin equals to 0.5 volt. So now you know that which graph you need to follow. Vin is increasing from minus infinity to plus infinity. Here it is decreasing from plus infinity to minus infinity. In this one, Vin is decreasing. Here Vin is increasing. So now I need to listen to this graph. And what this graph is saying? This graph is saying that at 0.5 volt your answer should be minus 1 volt. So at 0.5 volt your answer should be minus 1 volt. And in the next one, when Vin decreases from plus infinity to minus infinity, from plus infinity to minus infinity, when Vin is going here, so at Vin equals to 0.5 volt, what should be the answer? So at Vin equals to 0.5 volt, answer should be plus 1. Are you getting this point? Now the next question is saying, comment whether the circuit is inverting configuration or non-inverting configuration. What do we mean by that? So first let's make this characteristics on one graph only. Here we made two graphs, right? Now we are going just to add this graph. What I'm gonna do, I'm gonna add this graph. So what I'm gonna do, first I will make this graph where the transition is at. In the first graph, the transition was at plus 2, right? So first I'm gonna make this graph. The transition was at plus 2. Then I am gonna make the other graph where transition is at minus 1 volt. Transition is at minus 1 volt. So I just combined both of them. I just combined both of the graphs. So now let's see what we can tell. Well and good. So this is how I combined both of the graph. This is 1 volt. So what do you see here? This was, what was this value? Minus 1 volt. So what do you see here is that for higher value of Vin, like after 2 volt, for higher value of Vin, your output is high, right? And for lower value of Vin, your output is low. If you have studied your digital electronics, you would have studied two kind of circuit. One is buffer, one is inverter. In buffer, what happens? If I apply 1 here, I get 1 only. And in inverter, what happens? If I apply 0, I get 1. And if I apply 1, I get 0, right? Here if I apply 1, I get 1. If I apply 0, I get 0. If I apply 0 here, I get 1. If I apply 1 here, I get 0. So here what is happening? For higher value of input, you are getting higher output. For lower value of input, you are getting lower output. But in between, there is a dead zone that you don't know. In between, I will say that I need to know from where to where I am working. But if I am greater than 2 volt, then no matter how from where to where I am working, if I am greater than 2 volt, then always my output will be 1 volt. And if I am lesser than minus 1 volt, then my always output will be minus 1 volt. That means for higher value of input, it is getting high output. For lower value of input, it is getting lower output. So what kind of configuration is that? Non-inverting, right? So what kind of configuration is that? Non-inverting. So what kind of configuration? Non-inverting. Sir, how we will make inverting configuration? So watch the video, we will make inverting configuration as well. Till now, we do not even make non-inverting configuration. It is just the characteristics that is given. But now we need to design it. That how to make this kind of particular circuit. So now our target is clear. Our target is we need to design this kind of circuitry. Can we do it using diode? No. Using diode, what kind of characteristics we were getting? This kind of characteristics we were getting. So using diode, you cannot generate this kind of characteristics. So what you need to use? OpAmp. So there we will use OpAmp. So as of now, all these things are clear or not? Right? So this is how we studied this particular characteristics and we got to know what is the meaning of these arrows and everything. Right? Secondly, like we will define some terms here now. So minus 1 is a threshold voltage, no? Like after minus 1, there is a transition. So whenever there is a transition, that point is known as threshold voltage. So minus 1 is a threshold voltage. And 2 volt is also a threshold voltage because at 2 volt there is a transition, at minus 1 volt there is a transition. So minus 1 volt is known as lower threshold voltage. Okay, lower threshold potential, you can say lower threshold potential, and plus 2 is known as upper threshold potential. Why it is known as upper threshold potential? Because this value is higher and this value is lower, that's why it is known as lower threshold potential. There is no other concept. Like some people will say that it is known as upper threshold potential because after that output is plus 1 volt. No, this is not the reason. The reason is this value is higher, that's why it is upper threshold voltage. And this value is lower, That's why it is lower threshold voltage. There is no meaning of output. The term upper threshold voltage and lower threshold voltage is not defined with respect to output. It is only defined with respect to input. The threshold potential means the where output is changing, where there is a transition. So there is a transition at plus 2 volt. There is a transition at plus 1 volt. So there we are having two threshold, plus 2 and minus 1. So plus 2 is our upper threshold voltage and minus 1 is our lower threshold voltage, just because this value is lower, this value is larger. Now this is known as hysteresis width. Okay, what it is known as? Hysteresis width. Hysteresis width. VH, hysteresis width. So what is hysteresis width here? 2 minus minus 1. 2 minus minus 1. So hysteresis width is 3 volt here. Okay, and this zone is known as this zone. Look, this is here output will be plus 1, here output will be minus 1. But in this zone, I cannot comment what will be the output. It depends from where to where my input is going. So this zone is known as dead zone. Dead zone. Okay. So hysteresis width, upper threshold voltage, lower threshold voltage. So have you defined these terms? Well and good. Okay. Now we need to get started with OpAmp. But first let's see the basic concept of feedback. So what do you mean by negative feedback? What do you mean by positive feedback? So in negative feedback, what happens? Output is multiplied with a particular factor and it is coming back towards the input side. But it will be subtracted from the input, negative sign. Here output will be multiplied with a particular factor, but this will be added with the input, right? Whenever you need to check the feedback, how do you check the feedback? You nullify the input sources, Vin will be gone. You nullify the input sources. Now what do I do? Let's talk about negative feedback. So what I will do now, if I increase my V naught, just by a small amount, I increase my V naught. Like there is no input, let's just say there is some noise. Because of some noise, V naught increases. Now what will happen? This beta V naught will also increase, right? Because if V naught increases, this feedback factor, this will be a certain number. It could be half, it could be 1 by 4, it could be anything. So if V naught increases, then beta V naught will also increase. Now if this quantity is increasing, so here what you are getting? V in minus beta V naught. V in minus beta V naught. So since V in is gone, so here what you are getting? Minus beta V naught. So here beta V naught is increasing, but there is a negative sign, no? That means beta minus beta V naught is decreasing. Are you getting this point? If I increase V naught, beta V naught will increase, but there is a negative sign. That means minus beta V naught is decreasing. Now this decreasing quantity is multiplied with the gain. This decreasing quantity is multiplied with the gain A. That means decreasing is multiplied with gain A. Gain A will be a constant number. It would be 2, 3, 4, 5. It would be anything. So if this guy is decreasing, that means V naught will decrease. Say yes or no. So when you tried increasing V naught, beta V naught increased, this quantity decreased, and eventually your V naught decreased. Now this V naught is decreased. So this node is also decreased. If this is decreasing, that means beta V naught is decreasing. If beta V naught is decreasing, that means minus beta V naught is increasing. And if this guy is increasing, that means A into anything, that will increase. Now if it again increases, this will decrease. If V naught is again increasing, then this will increase, this will decrease, and then eventually it will decrease. If this is decreasing, then eventually it will increase. So what you are seeing here, once you tried increasing V naught, then when you walk around the loop and when you again come back to V naught, at that time V naught is going down. Now if V naught is going down, you again walk towards the loop, then V naught is going up. So what happened was, initially your output tried to go to higher side, but then it is again pushed back. Then again it tried to go higher side, then again it is pushed back. Again higher, pushed back. Then it will go towards a steady state. What do we mean here is that your output will not keep on increasing. That means it is not going towards instability, or your output will not keep on decreasing. That means also it is not going towards instability. That means here output will be certain, output will be fixed. That's why we say that in negative feedback we can avoid getting the condition of plus minus V set, but in positive feedback we get plus minus V set. What is the reason behind that? Why we get plus minus V set in positive feedback? Let's check that out. So here you go to know that output is stable. That means negative feedback circuit are stable. But what happens in positive feedback? If I increase this output, what will happen? This node will increase. Here what is going? Beta V naught is going. There is no negative sign. So this node will increase. If this is increasing into A, this will increase only. If this increases, then again this increases, then again this increases, then again this will increase. So it will keep on increasing, right? I just increased the output by a small amount. Just by a small amount I increased it. Now it will keep on increasing. Let's just say instead of increasing, initially I would have decreased it. Initially I would have decreased it. So if this is decreasing, then what will happen? This will also decrease. Let me use different color of pen, because let's just say initially I would have decreased it. So if this is decreasing, then this is also decreasing. If this is decreasing, then this is also decreasing. If this also decreases, then finally it is decreasing only. Then more it will decrease, more it will decrease, more it will decrease. So if I try to increase a bit, it is continuously increasing. If I try to decrease a bit, it will continuously decrease. And in OpAmp, the output cannot continuously decrease. It can have maximum plus Vset and minimum minus Vset. That's why we say in positive feedback we get plus minus Vset at output. But in negative feedback we can apply the concept of virtual short, and we can avoid getting the condition of plus minus Vset output. Are you able to understand this point or not? So in positive feedback, when we use that as an OpAmp, in OpAmp if we apply positive feedback, at that time we will have only two kind of output, that is plus Vset and minus Vset. So now you are using a OpAmp circuit in positive feedback. So what kind of feedback is there? Positive feedback. Just because there is a positive sign, that means it is a positive feedback? No. For checking positive feedback, what we need to do? We will nullify this input source. What we will do? If I increase this node, then what will happen? This node will also increase. Now, if positive node increases, then output increases. Right? That's why it is a positive feedback. So if this increases, this node also increases, then this node will also increase. So it will keep on. Are you able to understand why this node is increasing? Because this is simple potential divider, no? So if V node is increasing, then this node is increasing, then output is increasing. So all time output will keep on increasing. That's why there is a positive feedback. So there is a positive feedback, then I know that my output could be either plus Vset or minus Vset. So there are, and this circuit are same only. These two are same. This is just a different way of representing the circuit. So I can only have two outputs. It could be plus Vset or minus Vset. So initially I have to assume a particular output. Okay. How do we analyze this kind of circuit? So initially I have to assume a particular output, whether it is plus Vset or minus Vset. So what I'm gonna do? I'm assuming my output to be plus Vset. If your output is plus Vset, can you let me know what will be the potential here? V positive potential. So your V positive potential will be what? Simply this will drive 0 ampere current. So how I can write down this potential? Have you seen this circuit anywhere? If here you are having V1, here you are having V2, this is your R2 and this is your R1. Can you write down the potential of Vx? What will be the potential of Vx? You can apply the nodal analysis. I will directly write down the potential of Vx. That will help you a lot in the examination. V1 into R2 plus V2 into R1 divided by R1 plus R2. You can apply the nodal analysis, you will get the same expression. Okay. What will be the potential Vx? V1 into R2 plus V2 into R1 divided by R1 plus R2. So similarly here, output is plus Vset. Output is plus Vset. So what will be the potential here? Plus Vset into R1 plus Vset into R1 into V into plus Vset into R1 plus V into R2 divided by R1 plus R2. Right? Now, if your V positive is greater than V negative, then only output will be plus Vset. No, there is your assumption that your output is initially plus Vset. This is what you are assuming. But your assumption will be true only when your V positive is greater than V negative. So if my V positive is greater than V negative, then only my output will be plus Vset, right? What is my V positive? My V positive is Vset into R1 plus V in into R2 divided by R1 plus R2. It should be greater than V negative. What is your V negative? V negative is 0. So what you are getting? Vset into R1 plus V in into R2 should be greater than 0. What is our target? Our target is to draw the transfer characteristics. So your V in will be varying. So I need to get the relation with respect to V in. So what I am getting? V in into R2 should be greater than minus Vset into R1. So V in is greater than minus Vset into R1 by R2. So this is the condition I am getting. So if V in is greater than minus Vset into R1 by R2, then my output is plus V set. And if I just invert the sign, if I invert the sign that V positive is less than V negative, if V positive is less than V negative, then what will be your output? Output will be minus V set. So if I have just changed the sign, then what will be the condition? That if V in is less than minus V set into R1, just if I have changed the sign, I will do the same calculation. This arrow will change, right? Greater than will become lesser than, nothing else. So this will be the condition. So from here, what did you get to know? What did you assume first? Now, what is the conclusion of this analysis? What did you assume first is that we assumed first we assumed our output V0 to be plus V set. Then we got to know that if my V in is greater than minus V set into R1 divided by R2, then your output will be plus V set. But if your V in is less than minus V set into R1 by R2, then your output will be minus V set. Can you draw the transfer characteristics? Yes, sir, I can draw the transfer characteristics, but there will be a very important point to note. What you will say? That, sir, minus V set into R1 by R2, this point will be there. Minus V set into R1 by R2. So this is the point. Let me see one thing. Yeah, okay. So this is the point where things are changing. So, sir, if your value is lesser than this one, then output is minus V set. If your value is lesser than this one, then your output is minus V set. Otherwise, this will be plus V set. Now, the important point is where will be the arrow sign? That is the important point. Where will be the arrow sign? Arrow sign will be going towards from plus V set to minus V set, because what did you assume first? You assumed the output to be plus V set first. So you were at plus V set. Then what did you do? You were at plus V set, that means you were somewhere here. Then what did you do? You keep on decreasing your input. I keep on decreasing my input. When I did my input lesser than this one, then what did I see? My output is going towards minus V set. I was initially at plus V set. That means my input was higher. So when I kept on decreasing it, I got to know that I am going towards minus V set. So I started with plus V set, and now I have went towards minus V set. So this is how the arrow will come. Now this is how you will read the characteristics. So this was the important point. Arrow was the important point. That's why I say first we are making an assumption that we are assuming our output to be plus V set. Now you made this assumption, right? Let V0 is plus V set. You could have made this assumption as well. Which assumption? You could have made this assumption as well. That, sir, initially I would have assumed my output to be minus V set. Yes, there is no issue. Then what would have been your V positive value? The same analysis you are going to do. What would have been your V positive value? V positive would have been minus V set into R1 plus V in into R2 divided by R1 plus R2. So minus V set into R1 plus V in into R2 divided by R1 plus R2. So what you have assumed, V0 equals to minus V set. Now V0 equals to minus V set. If I have assumed V0 equals to minus V set, this will be only true if your V negative is greater than V positive, right? Or you can say my V positive is less than V negative. If my V positive is less than V negative, then only it is true. No, I have assumed it that my V0 is equals to minus V set. So initially I am at minus V set. So that means certainly this is the condition I am achieving, that my V positive is less than minus V negative, then only I will be at minus V set. So what is my V positive? Plus V in into R2 divided by R1 plus R2. Just a second, I need to drink water. Yeah, so where were we? So what we are doing, your V in, if I solve this equation, what I am getting, V in should be less than V set into R1 divided by R2. So what is the meaning? That you are assuming your output is minus V set. That means certainly you are satisfying this equation. Then only your output would be minus V set. No. So your input was actually this. Your input was actually lesser than this quantity. Then only your condition would have been satisfied. Now what you will do? You will increase your input. Let's just say my input goes above V set into R1 by R2. If it goes above V set into R1 by R2, that means my output would have moved towards plus V set. So initially, if I draw the characteristics here, what happened here? Initially, I assumed my output to be minus V set. Initially, I assumed my output to be minus V set. So actually, if I assume my output to be minus V set, that means my input should have been lesser than this particular quantity, which is this one, V set into R1 by R2. So if I have assumed my output to be if I have assumed my output to be minus V set, that means my input would have been lesser than this quantity. But after this particular value, my output would have been plus V set. So I started from here. I was happy with minus V set. Then what did I do? I kept on increasing the input value. And when I reached at this condition, that when I increased my input such that your input has gone above V set into R1 by R2, then my output went to plus V set. Are you understanding the direction of arrow? So first, whatever your assumption is, you are standing there. And with respect to your assumption, what should have been your input? Then what did you do? You kept on increasing your input. And at one point, your output moved towards plus V set. Are you getting this point or not? So are you able to understand that why we are making those assumptions? We are making those assumptions by making sure that this is our input. Right? So we are getting two characteristics. This characteristics we have got and another characteristics, this characteristics we have got. So I will draw both of the characteristics on one page and then I will just add them up. So on one page only I am drawing both of the characteristics. So now I hope you are able to understand the concept behind positive feedback. The problem is we do not understand the concept behind positive feedback and just we keep on solving the problem. That's the problem. That's the issue, right? So in our first assumption, I was happy with plus V set. In our first assumption, let's make it with arrow as well. So in our first assumption, I was happy with positive feedback. Then what happened? I kept on increasing, sorry, not positive feedback, sorry. In our first assumption, I was happy with plus V set. Then what happened? I kept on decreasing my input. At some point, the output went to minus V set. And this point was minus V set into R1 by R2, right? This was the point. Minus V set into R1 by R2. And these arrow sign you are understanding, right? In our second assumption, what I was doing, I was happy with my minus V set, but I kept on increasing the input. When it crossed V set by R1 upon R2, when it crossed this value, V set into R1 by R2, after that, it went to plus V set. Okay. So if I combine both of them, so what do you see here? If I combine both of them, what do you see? This is for the assumption of minus V set. And this is for the assumption of plus V set. Happy with plus V set, but you decreased so much that you need to go like this. Okay, this point was minus V set into R1 by R2 and this point was plus V set into R1 by R2, V in. This is V naught. What kind of characteristics is that? Inverting or non-inverting? Non-inverting, because for higher value you are getting higher output, for lower value you are getting lower output. In between there is a dead zone. What is the hysteresis width? What is VUTP? Upper threshold volt potential. What is that? V set into R1 by R2. There are two thresholds, V set into R1 by R2 and other threshold is minus V set by R1, minus V set into R1 by R2. Okay, so one which is at higher value, that is your upper threshold, one which it has lower value, that is your lower threshold. What is your hysteresis width? 2 into V set R1 by R2. Okay. And what kind of characteristics you are getting? Non-inverting. And let's get back to the circuit. Where was your input applied? Your input was applied towards the non-inverting side. This side is known as inverting because there is a negative sign, and this is known as non-inverting. So your input was applied at non-inverting side. So just as you see that my input is applied at non-inverting side, my input is applied at non-inverting side. That means it is your non-inverting Schmitt trigger. But the reason is not this, that your input is applied towards negative sign. That's why it is non-inverting Schmitt trigger. No, this is not the reason. The reason is the characteristics. When you get the final characteristics, you get to know that for higher value of input you are getting plus V set, for lower value of input you are getting minus V set. So this is the reason why this is known as non-inverting Schmitt trigger. Are you getting this point or not? Non-inverting Schmitt trigger. Okay. So what is a non-inverting Schmitt trigger? So let me show you with the circuit, with the block diagram. If we just make a block, so in the examination you will not have to do this much of analysis to get to the final answer. I will tell you a shortcut as well, but first we need to understand the concept. Otherwise with the shortcut you will not be able to solve the problem, at least in 2025 or 2026, because now the level of problem has gone up. So they know that if you know just trick, then you will not be able to solve, but if you know the concept, then certainly you will be able to attempt. So now on a block diagram, what I can represent? On a block diagram, I will make it as a buffer like this. I will make it as a buffer like this. What I am saying, in the examination the block can also be given. It's not necessary that it's not necessary that they will give this particular circuitry. They can avoid giving this circuitry. They will just give the block and then they expect you to analyze the circuit. What they will write? That it is your non-inverting Schmitt trigger. They can write this thing, non-inverting Schmitt trigger. Schmitt trigger. They will also give that it is having two thresholds. One is UTP, other one is LTP. Okay, so it is having two threshold. One is UTP, one is LTP. VUTP, VLTP. If your input is higher than VUTP, then your output, if your input is higher than VUTP, so here your output will be plus V set. Since it is non-inverting, the word non-inverting is very important. And if your input is lower than LTP, if your input is lower than LTP, then your output will be minus V set. In between there will be dead zone. Say yes or no. Okay. So this is the conclusion of your non-inverting Schmitt trigger. So this should be there in your mind. Okay, non-inverting Schmitt trigger. That means for higher value it will give higher output, lower value it will give lower output. In between there is a dead zone. So how will you make the characteristics directly? How will you tell these UTP, LTP directly? So let's check that out. So now it is like a trick or it is like a method also you can tell. So how you will tell finding UTP and LTP? So what you are going to do? So first thing is that I will find my V positive potential. What is my V positive potential? V positive potential is V0 into R1 plus V into R2 divided by R1 plus R2. Now you just let me know one point. When there is a transition, at the transition V positive is greater than V negative or V positive is less than V negative, no? That means when both of them becomes equal, V positive becomes to V negative, at that point transition takes place. Do you agree to this point or not? When your V positive becomes equal to V negative, at that point transition takes place. So here I am not applying the virtual short. I am just telling you a method. What you are going to do is that first you will find V positive, then you will equate your V positive to V negative. And now you will take two conditions, that first you will assume your output to be plus V set, and then second you will assume your output to be minus V set, and based on that you will find the value of V. So what I will do, what I have done is that first I have found out my V positive, then I will equate it to V negative. But how I will equate? First I will assume my output to be plus V set. If I assume my output to be plus V set, what I am getting? Plus V set into R1 plus V set into R1 plus V in into R2 divided by R1 plus R2. And then I will equate it to 0. What is 0? 0. I am not equating it to 0. I am equating it to V negative. I'm equating it to V negative. Whatever the potential is given at this particular potential, I'm equating it to that particular potential. Okay. The next, I will assume output to be minus V set. So minus V set into R1 plus V in into R2 divided by R1 plus R2. So from here what I am getting, my input value equals to minus V set into R1 minus V set into R1 divided by R2. This is one of the value I am getting, and another value I will get is V set into R1 divided by R2. So this will be the another value I will get. These two are your threshold potentials. The one which is higher value, this will be your VUTP. So from here you go to know that one which is higher value, this will be of higher value. So this is my UTP, and one which is at lower value, that will be your LTP. So did you understand what you need to do? Just first take the output to be plus V set, then take the output to be minus V set, get the V positive potential. Kind of you are applying virtual short. Just remember that kind of I am applying virtual short with respect to output plus V set and minus V set. So from there I will get my two threshold voltages. The one which is at higher value, that will be upper threshold, one which is at lower value, that will be lower threshold. Now how will I draw the characteristics? So first what I will do is that I will see the circuit. When I see the circuit, what did I get to know? That it is my non-inverting Schmitt trigger. What it is? It is my non-inverting Schmitt trigger. And one thing I know, that how will my characteristics look like? How will my characteristics look like? That in between there will be a dead zone. And what kind of a Schmitt trigger it is? Non-inverting. Non-inverting. So what I am doing, in between there will be a dead zone. That means two kind of output are possible. And here there will be transition. Here there will be transition. This point will be VUTP. This point will be VLTP. Transition will be at VUTP and VLTP. For higher value of input, V in, V out. For higher value of input, I will get higher output. Since it is non-inverting, very important point. Since it is non-inverting, that's why for higher value of input, I will get higher output. For lower value of input, I will get lower output. So this is how I will make the characteristics. That in between there is a dead zone. For higher value, you are getting higher output. For lower value, you are getting lower output. Now it will be about arrow. So when you come to this characteristics, what did you get to know? Just see the dead zone. It is moving anti-clockwise. So in non-inverting amplifier, you move anti-clockwise. In non-inverting amplifier, you move anti-clockwise. Now, will it be tough to remember? No, it will not be tough to remember. What it is? Non-inverting. That means it is positive. It is positive. When you take positive angle in mathematics, in anywhere, when you take positive angle, how do you move? Anti-clockwise. When I take positive angle, how do I move? Anti-clockwise. When I take positive angle, how do I move? Anti-clockwise. So whenever we are positive in our complete electronics engineering, whenever we are positive, we always move anti-clockwise. So if it is non-inverting, how I will move? Anti-clockwise. So this is how the movement will look like. Say yes or no. Movement will look something like this. So inside the characteristics, the movement will look something like this. What about these? What about these guys? Here both side will be arrow, no? Here both side will be arrow. Here arrow doesn't matter. Here both side will be arrow. You can check here, right? When you combine both of the characteristics, here also there was arrow. This arrow was there, and here also this was arrow. So here arrow will be on both of the side. So did you understand the trick how you will analyze the circuit within seconds? Any circuitry it could be given. V positive equals to V negative you will do. Threshold you got to know. Then you will make the dead zone. You know that since it is non-inverting, so at higher value of input, you will get higher output. At lower value of input, you will get lower output. Then it's about arrow. You saw that it is non-inverting. If it is non-inverting, that means it will be anti-clockwise. But just remember one thing, in Smith chart, when we study about standing wave pattern, then we make a VSWR circle. So in that Smith chart, we always move clockwise. So this is the only point in your complete electronics where clockwise matters. Okay. In Smith chart, we always move clockwise, not anti-clockwise. So that's the only point that matters in your complete electronics. But yeah, here we will always move anti-clockwise. Why is that so? Because this is your non-inverting Schmitt trigger. Non-inverting means it is positive, and whenever we are positive in electronics, we move anti-clockwise only. So this will be the anti-clockwise characteristics. Here both arrow will be there, here both arrow will be there. Now can you read the characteristics? Like if this characteristic is given, can I break it down into two parts? Yes. How will you break it down into two parts? That sir, for higher value you will get higher output, and this is the threshold. Okay. Sorry. So can you break it down into two parts? How will you break it down into two parts? That's the thing. So you need to see the sign of arrow. If I am making for this one, arrow is going this way, this way, this way. Let's see this sign only, this way. First you will make this characteristics, then you need to break it down this way, this way, this way, this way, this, and it is going here. So something like this, it will be broken. This way, this way, this way, this way, this way. So this is one characteristics. Other characteristics, you see the arrow going like this, going like this, going like this, going like this, going upward and downward. You see, going like this, going like this, going like this, like this, like this, upward, 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 and then out. Upward, 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 then out. So just a trick I am telling you, that how will you analyze the circuit. Okay, there is very high chance that in the examination they will ask you directly this characteristics. So there you will not do this kind of analysis there. That sir, first this will come, and if there is some complex circuit, then you can do the analysis as well. Analysis will also not take some time. Output you assume plus V set, then you get your condition that I was at plus V set, then at what condition I am going towards minus V set. Output you assume your minus V set, then at what condition I am going towards plus V set. That's it, you will get the characteristics. So analysis also will not take some time, but if you are in very hurry, then you can just apply the shortcut method. So just answer this question to me. Find UTP, LTP and all these things. Okay, what kind of feedback is there? Only positive feedback is there. Negative feedback is not there. Feedback means from output some part should come towards input. So no part is coming from output towards the input. So only positive feedback is there, right? So what we need to find? UTP, LTP, hysteresis width we need to find, and then we need to draw the transfer characteristics. So what did I tell you? First find out your V positive. What will be my V positive? V in into 2R, V in into 2R plus V naught into R plus V naught into R divided by 2R plus R, 3R. So 2V in plus V naught by 3. What is your V negative? V negative is, this will drive 0 ampere current, so simply you can divide the potential. So what will be your V negative? 3 into R divided by 2R plus R. So it will be 1 volt. So your V positive is this guy and V negative is this guy. So what we need to take? First we need to assume plus V set, then we need to assume minus V set. So what I am going to do? First I am going to add a page. So what I am going to do? If I assume my output would be plus 5, if I assume my output is plus 5 volt, so what I will get here? 2 into V in plus 5, output is plus 5, right? 2 into V in plus 5 divided by 3, and I need to equate it to 1 volt. So what I am getting? V in equals to 3 minus 5 minus 1 volt, sorry. V in equals to minus 1 volt. So this is one of my threshold voltage. What could be the other threshold voltage? For the other threshold voltage, I need to take, what is the negative threshold? Just see this. This is not minus 5. This is minus 3. It could be anything, right? It could be 0 as well. Negative threshold is minus 3. So what I am going to do? 2V in minus 3 divided by 3. That is equals to 1. So what you are getting? 3 you are getting, no? 3 plus 3 is 6. 6 divided by 2. So V in equals to 3 you are getting. So what did you see here? Which one is higher? This one is higher. So which is your UTP, which is your LTP? So from here I got to know that my UTP is 3 volt, my LTP is minus 1 volt. So let me know what will be your hysteresis width. 3 minus minus 1, it would be 4 volt. So hysteresis width will be 4 volt. So this will be the hysteresis width. If they ask you to draw the transfer characteristics, what you are going to do? First thing is that you are going to see the circuit. You will see where your input is applied. Input is applied towards the non-inverting side. What does that mean? It is non-inverting Schmitt trigger. Then you know that there will be a dead zone. So I can quickly make the dead zone. This will be the dead zone. Now I know one more thing, that in the dead zone, how will be the circulation? Circulation will be anti-clockwise. Non-inverting means anti-clockwise. So this is how the circulation will be. Just wait a second. This will not be symmetric, right? The graph will not be symmetric because lower threshold voltage is minus 1 and upper is plus 3. So the graph will not be symmetric. So let me make it in a better manner. So graph will be somewhat like this. this is minus 1 volt and this is plus 3 volt. I got to know that this is your output, this is your input. I know that it is my non-inverting Schmitt trigger, anti-clockwise rotation would be there. And one more thing, for higher value of input, you will get higher output. For higher value of input, you will get higher output, and for lower value of input, you will get lower output. And here I can make arrows on both of the side. This side, this side, this side, this side. Here also, this side, this side, this side, this side. And can I read the characteristics? Yes. This is how it is going. Arrow, 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 going here, going here, going here, going upward. This is how it is going. Going here, 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 and here, like this. So this is how the characteristics is done. Within 2 minutes, you will be able to solve these kind of problems. Okay, otherwise it becomes very difficult. Like people don't even understand the analysis first. So that's why I gave the analysis. Otherwise, I would have only told the problem solving skills. But I know that you struggle in the analysis of Schmitt trigger. You don't even know what is this characteristics. So if now you are comfortable, now you are completely comfortable about these all characteristics and everything. Now what we need to see, we have made non-inverting characteristics. That means for higher value of output, what I am saying, what characteristics we have made? We have made that for higher value of input, you are getting higher output. For lower value of input, you are getting lower output. But what if I need to design something that for higher value of input, I get lower output, and for lower value of input, I get higher output. So what kind of characteristics you want to make? In your rough notebook, you make that characteristics, then match it. Later on, after solving one more problem, I guess. So there is one more question. After this question, we are going to make that particular characteristics. So you will analyze this on your own. You will make the characteristics on your own. But before making the characteristics, first let me know that what is your target. What should be my target? My target initially was for getting higher value. I have made a buffer. Now my target is to make an inverter. That for higher value I get lower, for lower value I get higher. In between there is a dead zone. So try making the characteristics. What kind of characteristics you will make? And then you are having a circuit. Here I am already giving you a circuit. And try analyzing it in the same manner that you have analyzed. First assume output to be plus V set, then check the condition, then assume output to be minus V set, then check the condition, and then you understand how you are working. If you assume plus V set, that means where you are, and where you want from plus V set to minus V set, how you are going. So do all this analysis, and before that you can solve this question as well. This is also very easy only. So in the examination, this kind of question can be mentioned. The following sinusoid is applied to a non-inverting Schmitt trigger with threshold voltage of plus 3 and minus 3. They will not give the circuit. They have just said that it is non-inverting Schmitt trigger, right? So you know the characteristics of non-inverting Schmitt trigger. You are supposed to know the characteristics of non-inverting Schmitt trigger. Non-inverting means higher value will give plus V set, lower value will give minus V set. In between there is a dead zone, and arrow sign also you need to make. Then how will the output look like? So think about it and try making this waveform, and then try analyzing this particular circuitry. So spend some 10 to 15 minutes in your rough notebook on your own, and then start watching the video again. Okay. So yeah, I will take a pause because I am kind of I need a break now, but I will come back and then we will start analyzing from this particular question. Then we will analyze this circuitry as well. Okay then, yeah. So let me take a pause. Then you do the rough work in your notebook. Yeah, welcome back. So let's get started. So when you see this question, what you will understand that first, sir, I will have to draw the transfer characteristics because that is the primary task. Let's take this waveform somewhere aside. So first, sir, I will have to draw the transfer characteristics because they have given non-inverting Schmitt trigger. They did not even give the circuit. They have given nothing. So now I know how to draw the transfer characteristics. Sir, what I'm gonna do? There will be a dead zone. I know the threshold voltage is. It will be minus 3 and plus 3 volt. Since it is non-inverting, that means for greater value it will be plus V set. For lower value it will be minus V set. And I know the rotation as well. This is how the rotation should be there. Since it is non-inverting, rotation will be anti-clockwise, right? And here both sign of arrow will come. Here also both sign of arrow will come, right? Now, either I can analyze from this particular characteristics as well, or what I can do, I can break it down. I can break it down into two characteristics. If I break it down, then it will be easier for me. It will be easier for me to look at the circuit, nothing else. So I am breaking it down now. So how I can break it down? I can see that, let's see the arrow that is going this side. So if my input is increasing, then this is how the arrow is going, no? Input is increasing like this. So this is how the arrow is going. So how my characteristics will look like? If input is increasing, then change will be happening at 3 volt. Input is increasing like this, change is happening at 3 volt. This is your minus Vset, then you will have plus Vset. Saturation voltage will be mentioned actually. Okay. Then next, now your input is decreasing. This manner we are going. Input is decreasing. So what kind of characteristics we are getting? This kind of characteristics we are getting. So two kind of characteristics are there. These two kind of characteristics we can see. Okay. So this is your minus 3 volt. Well and good. So it is plus Vset, and then downward there is minus Vset. This is your V naught. This was also your V naught, and this is your V. Now you need to study the input. Within 1 minute you will be able to make all these things in the examination. Now you need to study the input and tell the output. Okay, and in the end I will tell you the not shortcut. I will actually tell you the concept that why this is happening. Okay, but first let's study the characteristics and then draw the output. So what is happening? Initially input is 0 volt. So at 0 volt, this guy will say that your output should be minus 5. This guy will say that output should be plus 5. So now you need to see minus 5 means I am calling saturation voltage as minus 5. So this guy will say that your output should be minus Vset. This guy is saying that output should be plus Vset. Now you need to see where your input is going. So what do you see? Your input is increasing. So this is how my input is going. My input is going from 0 to 5 volt. That means input is increasing. So in which characteristics input is increasing? In this characteristics. Because in this characteristics we are moving in this manner. So here my input is increasing, but in this characteristics my input is decreasing, right? So in this characteristics it is increasing. So if my input is increasing, right, input is increasing, so I will follow this characteristic. So what it is saying, at 0 your output should be minus Vset. So at 0 your output should be minus Vset. Till what point it should be minus Vset? Until your input increases to 3 volt. So until my input is increasing to 3 volt, my output should be minus Vset. After 3 volt, my output should be plus Vset. After 3 volt, my output should be plus Vset. So till 3 volt, output should be minus Vset only. But after that, output should be plus Vset. Minus Vset to after that, output should be plus Vset. When you are going from 3 to 5, when you are increasing from 3 to 5, so till 5 volt, output should be plus Vset. Now after 5 volt, what is happening? Input is decreasing. After 5 volt, input is decreasing to minus 5 volt. So if it is decreasing, that means I need to follow this characteristics now. Input is decreasing. So I need to follow this characteristics. Now what this characteristic is saying, if your input is increasing, that means till minus 3 volt, your output should be plus Vset only. Your input is decreasing from 5 volt to minus 5 volt it is going. So from 5 volt to minus 5 volt it will go. But till minus 3 volt, your output should be plus Vset only. So till minus 3 volt, where is my minus 3 volt? Till minus 3 volt, my output should be plus Vset only. Now, from minus 3 to minus 5 also input is decreasing only. Minus 3 to minus 5 also input is decreasing only. So this characteristics only I will follow. But what is this is saying? From minus 3 to minus 5 your output should be minus Vset. So what I will do? From minus 3 to minus 5 your output should be minus Vset. Now after minus 5 what is happening? Input is increasing. Input is again increasing. Input is again increasing. So I will again come back here. So it is increasing from minus 5 to plus 5. Your input is increasing from minus 5 to plus 5. So what this characteristic will say? That your input is increasing from minus 5 to plus 5. So until you cross 3 volt, your output should be minus Vset only. So until I cross 3 volt, where is my 3 volt? Here is my 3 volt. So until I cross 3 volt, my output should be minus Vset only. After that, it can go to plus Vset. Then again, from 3 to 5, my input is from 3 volt to 5 volt. My input is again increasing. From 3 volt to 5 volt, input is again increasing, and it is saying that your output should be plus Vset. It should be plus Vset. Then what will happen? After 5 volt, again it started decreasing. So again I will come back to this characteristics. So what will happen now? This cycle will keep on following. This cycle will keep on following. Where will be the next transition? Here will be the next transition. So let's draw it with the concept now. So what is the concept? First you need to understand what will be your initial output. Just as I understood that my initial output is minus Vset. Now the thing is you are at minus Vset. Now what you are doing? You are increasing your input. You are increasing your input in a manner that you want to go to plus Vset. If I am at minus Vset and I am increasing my input, what does that mean? That I want to go to plus Vset? No. Because what does your non-inverting Schmitt trigger says? That if you are going towards higher input, that means output should be higher only. If you are going towards a higher input, your output should be higher only. So you are increasing the input. That means you want to go towards a plus Vset. So you are increasing your input. So you started with minus Vset, you kept on increasing your input. Now what is the threshold voltage of this Schmitt trigger? Plus 3 volt and minus 3 volt. So now your Schmitt trigger will say that if you have crossed 3 volt, you started increasing the input. If you have crossed the 3 volt, then you can make the transition from minus Vset to plus Vset. So now you are in the region of plus Vset. You again kept on increasing your input. Schmitt trigger will say that if you keep on increasing your input, your output will be plus Vset only. But after 5 volt, what did you say? That now I want to decrease my input. Now I want to go towards my minus Vset. So you started decreasing your input. You decreased your input 5 volt, 4 volt, 3 volt. So what you will say? At 3 volt, can I make the transition? No. If I need to go to minus Vset, then I need to cross this threshold. If I am decreasing, I need to decrease as much as I can. And if I am increasing, I need to increase as much as I can. Here, I am in the zone of plus Vset. In this condition, I am in the zone of plus Vset now. Now, I started decreasing my input. Decreasing. Then I go to know that if I cross 3 volt, that doesn't mean my output will go to minus Vset. No. To go to minus Vset, I need to go to the least number. And my least threshold is minus 3 volt. So I need to go to minus 3 volt. Then the transition will take place. Now I am in the zone of minus Vset. So if I am keep on decreasing my input, then output will be minus Vset only. But after that, after minus 5 volt, what did I say? That I will try to increase my input now. So okay, I am increasing my input. If I am increasing my input, that means I want to go to plus Vset. If I am increasing my input, that means I want to go to plus Vset. So I increased my input. Then I go to know that if you want to go to plus Vset, then you need to cross the maximum threshold. So at minus 3 volt, you will not have the transition. You will have the transition at maximum threshold. Like I guess these dogs are also listening to the concept. Okay, so your transition will be at upper threshold. You are in the zone of minus Vset. Now you need to go to plus Vset. So I was in the zone of minus Vset. Now I need to go to plus Vset. That means I need to cross the upper threshold. And if I am in the zone of plus Vset and I want to go to minus Vset, then I need to cross the lower threshold. This is what your non-inverting Schmitt trigger says. But you cannot remember all these things in the examination. So what you are going to do? Just make the characteristics, follow the characteristics, draw the waveform. That's it. Now in the examination, what kind of question they can ask? They can ask that what will be the time period of this cycle? Okay, like time period, how will you calculate? You will calculate this angle. You can calculate this angle as well. This is signal system then. They will ask you the time period, they can ask the duty cycle as well. Right? So all these things they can ask. And here I gave the threshold voltage to be 3 minus 3. They can give 3 1 as well. They can give 3 minus 2 as well. So accordingly you will draw the waveform, you will draw the characteristics, then you will draw the waveform, and then you will tell the final answer. Well and good? Understood? Very easy concept. Did you try analyzing it on your own? Here input is applied to the inverting terminal. So what it will result in? Inverting Schmitt trigger. But before that, let's analyze it. What we need to do? We will assume an output. What we assume? First we need to assume the output. V naught is equals to plus Vset. Okay, let's start with minus Vset this time. There is no reason. I am just assuming any output. Let's start with minus Vset this time. Okay, I am starting with minus Vset. So what will happen? What will come here? So what will be your V positive? V positive will be minus Vset into R1 divided by R1 plus R2. What did I do? I simply applied this circuit and this circuit are same only. Okay, because this will drive 0 ampere current, so I can apply the potential division. So minus Vset into R1 divided by R1 plus R2. What about, so what is the condition? If you have assumed your output to be minus Vset, that means your V positive should be less than V negative. What is your V positive? V positive is minus Vset into R1 divided by R1 plus R2 should be less than V negative. V negative is V in. So what is the condition we are getting here? If your V in is greater than minus Vset R1 divided by R1 plus R2, then your output is minus Vset. So initially you are happy with minus Vset. Now what did you do? Now you want to go to plus Vset. So what is the condition of plus Vset? This is the condition of plus Vset. So initially you assumed your output to be minus Vset, but now you want to go to plus Vset. So what did you do? What kind of characteristics you are getting? Where is the transition point? The transition point is here. let's call, let R1 upon R1 plus R2 equals to beta. I am calling this as beta. Okay, what I am doing, I am calling this as beta so that I don't write to so that I don't need to write down complex numbers. So if this is beta, so what I am getting here, minus beta V set. So where is the transition? The transition is at minus beta V set. So what is happening? V naught versus V. So initially I was at minus V set. Initially I was at minus V set. Initially I was at minus V set. Then what happened? At minus beta V set, my transition took place and I went to plus V set. And I went to plus V set. And to plus V set. Did you understand the sign of arrow? I was at minus V set. Then what did I do? I kept on decreasing my input. I kept on decreasing my input. I kept on decreasing my input. When I kept on decreasing my input, I got to know that after a certain point, I am getting my output to be plus V set. So here what did you see? That for higher value you are getting minus V set. But for lower value you are getting plus V set. What was happening? Initially you assumed your output to be minus V set. If you have assumed your output to be minus V set, that means you are somewhere here. Then what did you do? You kept on decreasing your input. At a threshold point, at a certain point, after a certain point, your output became plus V set. After a certain point, your output became plus V set. So that means this is the characteristics you are getting. Is that clear to you? Right? Can we do the same for the next one? If I assume output to be plus V set. So I have assumed my output to be plus V set. What does that mean? That my V negative should be less than V positive. What is my V negative? V in. What is my V positive? That is V set into R1 upon R1 plus R2. Or you can say your V in is less than beta V set. So if it is less than beta V set, then you are happy with plus V set. But if you kept on increasing your input and you have increased it so much that it goes above plus beta V set, then your output goes to minus V set. Can you draw the characteristics? Yes. I am moving here faster because I have taken enough time to explain all these things, right? So now I can move a bit faster. This should have been done by you on your own because you are someone who has already studied it. So what is the scene? First I was happy with my plus V set. First I was happy with my plus V set. Then what did I do? I kept on, where is my plus V set? Where is my transition point? My transition point is beta V set. Transition point is this beta V set. Okay. So I was happy with plus V set. Here I was happy with plus V set. Then what did I do? I kept on decreasing my, okay, yeah, sorry. When V in is less than beta V set, when V in is less than beta V set, when V in is less than beta V set, I was at plus V set. So I was happy here. Then what did I do? I kept on increasing my input. When I increased it so much that it goes above plus beta V set, then my output goes to minus V set. Okay. So plus V set, minus V set. So are you able to understand the concept? What is happening here? For higher value of input, you are getting lower output. For lower value of input, you are getting higher output. So what did you assume? First you assume your output to be plus V set. Then what did you do? You kept on increasing your input. First you would have tried to decrease your input. Then you got to know that if I keep on decreasing the input, my output is still at plus V set only. So in this circuit, if I keep on decreasing my input, my output is at plus V set only. Then what did I try? I tried increasing the input. So when I increased it and I increased it to a limit that after a certain point it goes to minus V set. So this is how I am moving. And after that it is going to minus V set. Okay. Now how will you draw the transfer characteristics? Final transfer characteristics. You just need to add both of them. Certainly I will tell you a trick that how you can draw in the examination very quickly. So first one is this one, which I can directly see on the screen. And the second one is this one. It comes like this. Okay, this is minus beta V set. In which direction do you see that rotation of the dead zone? This is your dead zone, no? This is your hysteresis width. This is your dead zone. What is the direction of rotation? Clockwise, right? And what do you see? For higher value of input, you are getting lower output. For lower value of input, you are getting higher output. So what kind of characteristics is that? This is the characteristics of inverting. This is your inverting characteristics. Say yes or no. So in the examination, if it is mentioned inverting Schmitt trigger, will you be able to make the characteristics or not? Say yes or no. Certainly, sir, you will be able to make the characteristics. What is the shortcut? Shortcut is the same, ditto same. Finding UTP, LTP, how will you find? First, you will find the V positive potential. What will be your V positive potential? V naught into R1 upon R1 plus R2. Then what you need to do? You need to equate it to V negative, which is equals to V in. It could be anything. My target is V positive and V negative I will equate. When I equate them, I will get two values of V in. Because output value I will keep either plus V set or minus V set. When I get those two value, it will be UTP and LTP. Okay. So what I'm gonna do is that first I'm gonna assume output to be plus V set. So if I assume output to be plus V set, so V set into R1 upon R1 plus R2. So this value I am getting. This is the first value I am getting. Secondly, I'm gonna assume output to be minus V set. So here what I will get? Minus V set into R1 upon R1 plus R2. That will be the second value. So two values we are getting. One is UTP, one is LTP. So what is your VUTP? Your VUTP is V set into R1 upon R1 plus R2. And what is your VLTP? That is minus V set into R1 upon R1 plus R2. Will you mug it up? No. Just one method I have told you. With that method you can solve. Okay. Then what you need to do? You can draw that transfer characteristics. What you know, there will be a dead zone. So sir, directly I will make the dead zone. Since it is inverting characteristics, inverting, what is the meaning of inverting? What is the meaning of inverting? The meaning of inverting is that for higher value of input, you will get lower output. And for lower value of input, you will get higher output. Right? So this will be the characteristics now. Since it is inverting, what is the word? Inverting. So inverting means when do we take negative angle? Negative angle we take when we move clockwise. So I need to move clockwise now. So this is how I will move. So this is how I will move. So here both arrow sign will come. That doesn't matter. Here also both arrow sign will come. That doesn't matter. Can I break it down into two parts? Yes. Go on increasing the input. So if I increase the input, this is how I am going. And if I am decreasing the input, then this is how I am going. Right? So I can break it down into two parts as well. So within minutes, I will be able to solve the problem of Schmitt trigger, which feels like very difficult to me. But after this video, it will not feel like difficult to me. Right? So this is your V UTP and this is my V LTP. Right? Well and good. Okay, then this is the characteristics we have drawn. Let's see the conclusion then. Non-inverting Schmitt trigger conclusion we have already seen. Here, what is mentioned plus V set minus V set. But here I am mentioning it is upper threshold voltage and lower threshold voltage. Okay, anything can be mentioned in the examination. They can give upper threshold and lower threshold as well. They can give the saturation voltage as well. I am mentioning that this is a circuit I am having. This is like a buffer circuit I am having, and it is having upper threshold and lower threshold. So if your input is greater than upper threshold, then what will be your output? Plus V set. This is for non-inverting. And if it is lesser than that, then what is your output? Output will be minus V set. In between, what will be the scene? In between, the scene will be dead zone. Right? What about the inverting Schmitt trigger? What about the inverting Schmitt trigger? Inverting Schmitt trigger says the opposite. If it is greater, then output should be minus V set. And if it is lesser, then output should be plus V set. In between, what is the scene? In between, there is a dead zone. Okay. So here everything depends that how you will work. And will you be able to draw the characteristics as well? Certainly I will be able to draw the characteristics as well. Okay. LTP, UTP will be there. LTP, UTP. I know the process as well that I need to equate V positive to V negative. And if I am able to equate V positive to V negative, after that I can draw the characteristics as well. In non-inverting, I will move anti-clockwise. And in inverting, I will move clockwise. There you go. This is the complete conclusion. Yeah, hi everyone, welcome back. Actually, in between the screen went off. So the thing is, the previous part that I written down, that is not recorded now. So For this video, you will not get the PDF actually. Okay, so sorry for that, and please bear with it. You will not get the PDF. So you can see from the video itself, right? Okay, and since this is a revision video, so I don't think you would require any PDF. So what we are doing, we need to solve this question. You need to draw the transfer characteristics when R is equals to 1 kilo ohm and R is equals to 23.625 kilo ohm. Okay, so two conditions are there. Usually when we solve these kind of problems, we never take this R into action. This is what people does. They will say that okay, OpAmp will give 15 plus 15 volt output and minus 15 volt output. Then what will happen? This 15 volt is enough to take this like 15 volt will be enough to turn this diode on and to take one of the diode into breakdown, and then they solve the problem. But this is not the case. Here I have given different values of R, so now the things will be different. Okay, so if you have attempted these kind of problems before, now try attempting it on your own. The value of R will play a important role in this particular analysis. Okay, and now what I am doing is that first let me tell you what is the meaning of this particular circuitry. If you don't know the meaning of this particular circuitry, so what is this? This is just Zener, two Zener connected in series, one Zener and then another Zener connected in series. So these are nothing but Zener diode. These are two Zener diode in series. Well and good. Okay. Now here the thing is, your actual output of the circuit and your output of OpAmp both are two different things. This is the actual output of the circuit and this is the output of OpAmp. Now VA can be plus minus 15. VA will be plus minus 15. After VA there is a R. This configuration is there, and then there is a V naught. So VA can be plus minus 15, but V naught, for V naught you need to think. Are you getting this point? For V naught we need to think. It will depend on the operating condition of Zener diodes. So if I need to know the operating condition of Zener diode, then what we need to do? We need to apply the open circuit test. I hope you know how to analyze the operating condition of diodes. So what we need to do, we need to apply open circuit test. So what I am going to do is that this is my VA, right? From VA there is resistance R is connected. R value, we are solving for problem A. So R value is 1 kilo ohm. Then we are considering open circuit condition, right? Now from here, from V naught to directly what is connected? 10 kilo ohm is connected, right? 10 kilo ohm is connected. Then from 10 kilo ohm, what all things are connected? From 10 kilo ohm, one branch is going here, OpAmp is connected, and from 10 kilo ohm, other branch is connected to 0.5 kilo ohm, and then it is connected to 2 volt. So this is the scene, right? So here it is connected to this particular branch. So this particular branch is driving 0 ampere current, right? This is driving 0 ampere current. Input of OpAmp is driving 0 ampere current. So are you able to understand? Whatever the current that will be flowing from here, let's just say I current is flowing from here. Input of OpAmp drives 0 ampere current, but output of OpAmp can drive any amount of current. So if I current is flowing from here, the same I current will be flowing from here as well. The same I will be flowing from here as well. The same will be flowing from here as well, and the same will be flowing from here as well. So all three came into series. Are you able to understand this point? This R 10 kilo ohm and 0.5 kilo ohm, all three came into series. Now my task is to find this Vx potential. So all these three are in series. So I can apply anything, that formula that I told you, Va into R2 plus V2 into R1 divided by R1 plus R2, that you can apply, or you can apply nodal as well. Vx minus 2 divided by 10.5 plus Vx minus Va divided by 1 kilo ohm is equals to 0. That also you can apply. So Va, different condition we need to take. First we are taking Va equals to 15 volt. Okay, I am taking Va equals to 15 volt. So if Va is equals to 15 volt, my target is to get Vx value. If I get Vx value, then I can tell the operating condition of diode. If I am able to tell the operating condition of diode, then I can comment on the output, because this is my output only. Vx is my V out only actually. So let's first find the value of V out or Vx, whatever it is. So first we are assuming it to be Vx. So what is the value of Vx? 15 into 10.5 plus 2 into 1 divided by 11.5. Okay, let's do the calculation. 15 into 10.5 plus 2 divided by 11.5, 13.86 we are getting. 13.86 volt. So now what is the scene here at this point? Okay, let's go to the next one. So Vx value I am getting 13.86, and what is the condition? Zeners are connected in this manner. Now what you can see, this 13.86 is connected to the P terminal. This is N terminal. It is connected to the P terminal. So that 13.86 is enough to turn this diode on. So we can assume that this particular diode is on. This will not go into breakdown. This will not even go into reverse bias. This will go into forward bias. So this will be on. So this is enough to turn it on. So what is the potential here? 13.86. What is this? 0.7. So what you are going to get here? 13.16. So here you are going to get 13.16. Now at N side, how much potential you are having? 13.16. And at P side, how much potential you are having? 0. So that is enough to get into breakdown, because breakdown voltage is 6.3 volt. You only require 6.3 volt. So yeah, that is enough to get into breakdown. So now what will be the scene? This is 0.7, and N side will be replaced with P side. Sorry, N side will be replaced with positive side of battery, and P side will be replaced with the negative side of battery. So this will be the final circuitry. So this will be replaced with 6.3 volt battery. This will be replaced with 0.7 volt battery. So you are expecting that here you will get 13.86 volt. But since one of the diode turned on and one of the diode went into breakdown, so here the voltage will be 6.3 plus 0.7, 7 volt. So here actually you are getting 7 volt. So now your V out is coming out to be 7 volt. What was the condition? What I assumed? VA equals to, what we are solving? First we are solving for option A, when R was equals to 1 kilo ohm. So VA is coming out to be what? VA is coming out to be, no, why I am saying VA is coming out to be, VA I assume to be 15 volt. So if I assume VA to be 15 volt, then what is my V out is coming out to be 7 volt, because Vx is V out only, no? Vx is V out only. This Vx is V out only. So V naught is coming out to be 7 volt. So I just need to know what all are the values of V naught. And why I need to know the values of V naught? Why I need to know the values of V naught? Because in this particular circuit, what I'm gonna do, I see that this is a positive feedback circuit. So in positive feedback circuit, what did I tell you? First get the value of V positive and then equate it to V negative. So V negative value I already know. What is my V negative? What is my V negative? My V negative is equals to V in. I need to know the value of V positive. What is the value of V positive? My V positive is V naught into 0.5 plus 2 into 10, 20 divided by 10 plus 0.5, 10.5, right? V naught into 0.5 plus 2 into 20, sorry, 2 into 10 divided by 10.5. So this is my V positive value. So I will equate V positive to V negative, then I will get two values of V in, that will be UTP and LTP. And what do I know? This is your inverting Schmitt trigger. Why inverting? Because it is connected to negative terminal. So this is inverting Schmitt trigger. So I know how to draw the characteristics. But the main point is, what would be the values of V naught? So V naught is not directly connected to the output of OpAmp. In the previous questions, it was directly connected to the output of OpAmp. But now there is a resistance R, there is this particular circuitry, and then there is V naught. So that's the interesting part. That's why we are considered. That's why we are considered about V naught value. So in the examination, looking at the circuit directly, you will not tell us, okay, sir, Zener will come into action. This is what I have seen in a lot of lectures. This is what is taught, that they don't even care about this R value. You need to do this analysis. Then you will get to know the operating condition of Zener. Then you can comment, because here the scenes will change. That's why I took this example. No, in the examination, this question was asked. This is a gate PYQ only, but this was asked. Since this was asked, so every time people think that, okay, every time Zener will get into their breakdown condition or it will be turning on. But it is not necessary. It depends on the value of R. There was also value of R was given. But what if they give the value of R something like this? So here the scenes will change. But first let's analyze for minus 15 as well. What we need to do? Now we need to analyze for minus 15. So now I will analyze the same circuit for minus 15. I can take VA value to be minus 15 volt. Okay, so let me tell you what is the value of Vx. So minus 15 into 10.5 plus 2 into, is this 1 kilo ohm? 1 kilo ohm it was, no? This is the second analysis I am doing. When VA is equals to minus 15 volt. Minus 15, 1 kilo ohm, 10, 10.5. Yeah, minus 15 into 10.5 plus 2 into 1 divided by 11.5. What we are getting? 10.5 into 15 minus 2 divided by 11.5. So minus 13.52. Vx is minus 13.52 volt. Okay. So now what is the scene? This is your Zener. This is minus 13.52 volt. Okay. Now you know that this can go into breakdown because there is very high negative potential on the P side, and this can be turned on. This diode can be turned on and this can be taken into breakdown. So first I am assuming that this goes into breakdown. This guy goes into breakdown. So if this goes into breakdown, then what will happen? This will be replaced with negative terminal. This will be positive. P side negative, N side positive. When it goes into breakdown, opposite happens. So what will be the battery? 6.3 volt. It will be replaced with 6.3 volt. So now you are here you are having 13.52 minus 13.52. So minus 13.52 plus 6.3 minus 13.52 plus 6.3, roughly around here you will be getting minus 7 volt, minus 7 volt, and then you are having N and P. So P is at 0, N is at minus 7 volt, around minus 7 volt. So what will happen? This is enough to turn this diode on. So this will be going into forward bias. So this diode will be going into forward bias. Since it is going into forward bias, so negative will be negative only, positive will be positive only, and this is grounded. So this will be replaced with the battery of 0.7 volt. So what is the final scenario now? So final scenario, you can directly see that we expected it to be minus 13.52 volt, but we got to know that it is being, one of the diode is turning on and one of the diode is going into breakdown. So we got to know that what we are getting our Vx value, that is equals to V naught value, to be minus 7 volt. So what is the final conclusion we can see? When R was equals to 1 kilo ohm, this is the first question, when R was equals to 1 kilo ohm and we assumed our Va to be plus 15, then what we got? We got our V naught to be plus 7. And when we assumed our Va to be minus 15, we got our V naught to be minus 7. So we expected that our output should be plus minus 15, but since we connected this particular configuration R and Zener, so our output is restricted to 7 and minus 7. That's why we connected this particular circuitry. We connected this particular circuitry so that our output is restricted to plus minus 7 volt. Yeah, so now you are having V negative potential as well, V positive potential as well. You have the value of V naught as well. So directly you can find the V UTP and LTP. Okay. So what you can find now, V UTP and LTP. So what we need to do, V in, that is V negative, I will equate it to V naught into 0.5 plus 20 divided by, this is just a method, okay, this is not the analysis. We are not applying any virtual short here. This is just the method that I told you, that you just equate them, then put the values of V naught, and then you will understand whether it will be going into breakdown or not. So if I put 7 volt here, so 3.5, 23.5, 23.5 divided by 10.5, and one value you will get. What I am doing, first I have put 7 volt here, right? First I will put 7 volt, V naught equals to 7 volt. So for 7 volt, what value of V I am getting? 7 into 0.5, that will be 3.5, 3.5 plus 20, 23.5 divided by 10.5. And when V naught is equals to minus 7 volt, what will be your V in? Minus 3.5 plus 20, that is 16.5 divided by 10.5. So this is the answer we are getting. 23.5 divided by 10.5. 2.238. 2.238. 16.5 divided by 10.5. 1.57. 1. So what is your, which one will be UTP, which one will be LTP? This will be your UTP, this will be your LTP, right? Minus 2.238. So what you are getting, hysteresis width is coming out to be, hysteresis width is coming out to be 0.66 volt. Okay. Now can I draw the characteristics? Certainly I can draw the characteristics very easily, right? Hysteresis, I know, what do I know? That sir, this will result into hysteresis only. So hysteresis I can draw. Why I am drawing like this? Because both are positive, 1.57 and 2.23, right? And one thing, another thing I know, what is that? That for higher value of Vin you will get lower output. For higher value of Vin you will get lower output. For lower value of Vin you will get higher output. This is what we know, right? And since it is inverting amp, since it is inverting Schmitt trigger, so for inverting what we do, we will move clockwise, right? For inverting we move clockwise, okay? And here arrows on both of the side, arrows on both of the side. Well and good. So this is the final answer. So this was the first question. The second one is more interesting now. The second one is R equals to 23.625 kilo ohm. So you do the analysis on your own. You would be able to do it. Just you need to put 23.625 kilo ohm here. So what you will get? R is 23.625 kilo ohm. So here 23.625 kilo ohm. Then another resistance, and here you are having 2 volt and 2.5, 10 kilo ohm, 2.5. Again I am taking the diode in, I am applying open circuit test here. Here what I am gonna do, here I am gonna apply VA only. VA could be plus 15 and minus 15, anything. So I am using it to be plus 15 volt, and here 23.625 kilo ohm. So what I need to find? I need to find Vx. So what is Vx? Vx I need to find. So 15 into, it was 2.5, no 0.5, that's what I was thinking. This was 0.5. So 15 into 10.5, 15 into 10.5 plus 2 into 23.625 divided by 23.625 plus 0.5. This was kilo ohm as well. Mm, 23.625 plus 10.5. 23.625 plus 10.5. 34.125. So what we are getting? 15 into 10.5 plus 2 into 23.625 divided by 34.125. 6. Yeah. Vx is coming out to be 6 volt. Now, do you really think this 6 volt is enough to get into breakdown and all these kind of things? Let's check. So this was our circuitry. Right? Here what I am gonna assume, 6 volt. So now, yeah, it feels like that sir, this should be going into forward bias, because 6 volt is there. That should be enough to take it into forward bias. So what I will do, first I will try to take this into forward bias. So this I have taken into forward bias. So how much voltage drop it will give? 0.7. What I will be having here? 5.3. Now you let me know, is this 5.3 enough to take into breakdown? No. So now what will happen? It cannot go into breakdown. So where it will go? In reverse bias, because at N potential you are having 5.3, at P you are having 0. So where it will go? Reverse bias. So if you assume this to be forward bias, then this is going into reverse bias. So actually what happened is that if it is reverse bias, then what will happen? It will be open circuited. And if it is open circuited, then what will happen? There will be zero ampere current. And if there is 0 ampere current through the diode, what does that mean? That both diode are off only. So both diodes are off here. So here it is open circuited only. We assumed it to be open circuited, then we got to know that both diodes are off, so it will be always open circuited only. So here we connected Zener, but there was no use of those Zener diode. Are you getting this point? Okay. So in the examination, they can play with the value of R. So here there was no point of those Zener diodes. So actually the Zener diode was replaced with open circuit. And if Zeners are replaced with open circuit, then what will be my value of V naught? So Vx will be equals to V naught will be equals to 6 volt. It will not be plus 15. Now there is a resistance R, there is this 10 kilo ohm, there is 0.5 kilo ohm. So this resistance R will take some drop. That drop it will take. So Vx value will be 6 volt. This will be the value of Vx. Are you getting this point? Okay. So this was your Vx value we are getting. Now you can try for minus 15 as well. So if I apply minus 15 here, then for Va equals to minus 15. If I apply minus 15 here, so what will be the value of Vx I will be getting? Minus 15 into 10.5 plus 2 into 23.625 divided by 34.125. So what value of Vx I will get? 15 into 10.5 minus 2 into 3.625 divided by 34.125 minus 3.23 minus 3.23 volt. Okay. So now what is the condition? This is your Zener. This is your Zener. Here what you are having? Minus 3.23 volt. Do you really think this is enough to take this into breakdown? No. Minus 3.23 is not enough to take this into breakdown. You may feel like that, sir, minus 3.23 is enough to take this into forward bias. Yes. But even if it goes into forward bias, nothing will happen. Even if it goes into forward bias, still what will happen? Here there will be minus 0.7 volt. I am assuming that this is going into forward bias. So here there will be minus 0.7 volt. If there is minus 0.7 volt, then still this is not going into breakdown. So there is no chance that this will go into breakdown. And if it is not going into breakdown, then what does that mean? It will be in reverse bias. This diode will be in reverse bias. And if it is in reverse bias, that means it will drive 0 ampere current. Since both are connected in series, so this will also drive 0 ampere current. If both diodes are driving 0 ampere current, that means both will be open circuited. So this will be the final operating condition. And if both are open circuited, that means whatever the Vx value you are getting, the same value you will get for V naught as well. So this is your final V naught as well. So this time you have two V naught values, plus 6 and minus 3.23. So what we need to do, we will equate V in equals to V naught into 0.5 plus 20 divided by V naught into 0.5 plus 2 into 10, that is 20 divided by 10.5. V naught into 0.5 plus 2 into 10 divided by 10.5. Yeah. V naught into 0.5. This is what we used to do, right? Yeah. So now we need to put the values. V naught equals to 6 volt you will put. V naught equals to minus 3.23 volt you will put. So getting started, V naught equals to 6 volt I am putting. If I put 6 volt here, what I am gonna get? 3 plus 20 divided by 10.5. So 23 divided by 10.5. And V naught equals to minus 3.23 volt I will get. Minus 3.23. 3 into 0.5 plus 20 divided by 10.5. Okay. So 23 divided by 10.5. 2.19. and here 3.23 into 0.5 plus 20 divided by 10.5. So what you are getting 1.75. So did you understand the motive behind framing this problem? Did you understand the motive? The motive was that this R also has some importance. Okay, you do not give importance to R, so you need to give importance to R as well. Well and good. So, but let me tell you one thing, guys. Till now, whenever the question has been asked, okay, so always these guys were going into breakdown and forward bias. So let's just say in the examination, the paper comes out to be lengthy and you are not having enough time. If you are not having enough time and paper comes out to be lengthy, so going by the analysis of previous year questions, they are always going into breakdown and reverse bias. So what you can do, you can consider them into breakdown and reverse bias. If in the examination you are not having much time, so without even checking, by hit and trial blindly you can go them to take into forward bias and breakdown region. But if you are having time, then certainly check it. Or it might happen that in the examination they do not even give the value of R. So if they are not giving the value of R, that means certainly it is going into breakdown. If they are not giving the value of R, what does that mean? That certainly it is going into breakdown. Otherwise they would have given the value of R, no? Right? If they are not giving the value of R, that means they want this to go into breakdown. So this value of R user will put. Now user can put this much large value as well. If he is putting this much large value, then it is not actually going into breakdown. So here we go to know that answer is becoming different. Now our UTP, LTP both are different. So you can draw the characteristics. Characteristics will be same only. Here I am just writing hysteresis width. This will be your UTP. This will be your LTP. Right? So 25 plus 19, that will be 0.44. 0.44 volt. So this will be your hysteresis width. So in this manner we will solve the problem in the examination. Well and good. Let's go to the next question. Try this on your own. Again you need to apply open circuit test, short circuit test, the same thing. What kind of Schmitt trigger it is? Inverting. This is your inverting Schmitt trigger. So again you assume plus 10, minus 10, then you see what will are the operating condition of diode, which diode will turn on, and then what we need to find. Our target is to equate V positive to V negative. What do I know? I need to equate this thing. But this is not virtual short. This is just a method. By the method, we will equate this thing, then we can find our UTP, LTP. So what do I know? That my V negative is equals to V in. How do I get V positive? So for getting V positive, two kind of output I can have. What is one kind of output? That V naught could be plus 10 volt. If V naught is plus 10 volt, then which diode will turn on? This diode will turn on. Why is that so? You can apply open circuit test. If I apply open circuit test, what will happen? This is 0.5 kilo ohm, then diode is open circuited. Here 2 kilo ohm, diode is open circuited. Right? And this is the condition. Okay. Now what is the scene? OpAmp drives 0 ampere current. Since they are open circuited, we have considered them to be open circuited, so they will also take 0 ampere current. Here also there is 0 ampere current. So what will be the current through this 2 kilo ohm? That will also be 0 only. So this 2 kilo ohm is also taking 0 ampere current. So if there is 0 ampere current, so that means this voltage will be 0, because this is ground, so this voltage will be 0. So this is 0, this will also be 0, and there is no current through the resistance, so this and this potential will also be 0. So now what you are applying, we know to be 10 volt. Here 10 volt, here 10 volt. So now what do you see? At D2 you are having 10 and 0, so this will turn on, and D1 you are having 10 and 0, so this will be turned off. So this is how you can check. So what is happening here? D2 is turning on. D2 is turning on. If D2 is turning on, then what will happen? This 10 volt will travel and it will reach here. Now 2 kilo ohm will not be in action because D1 has turned off. D1 has turned off, so this 2 kilo ohm will not drive any current. So 10 volt has reached here. If the 10 volt has reached here, what does that mean? This is not even into action, and OpAmp is driving 0 ampere current, and 10 volt has reached here. So what will be the potential of V positive? What do you think? What is the potential of V positive? From V positive upper side there is no current. Here also there is no current. So I can directly apply potential division. No. So what will be the potential? 10 into 2 upon 2.5. So V positive will be 8 volt. Are you getting this point? Understood? So V positive will be 8 volt. What is our target? To equate V positive to V negative. So one value of V in you are getting as 8 volt. So this could be either UTP or LTP, that we need to check. Next is V0 equals to minus 10 volt. So in the same manner you will check, you will understand that D1 will turn on now. If D1 is turning on, then what will happen? D2 will be off. So this guy will not even come into action. If this guy is not coming into action, then what will happen? D1 is only turned on. This is turned on. Then what will happen? This will drive 0 ampere current. This will drive 0 ampere current. So now what will be the potential here? The potential will be divided between 2 and 2 kilo. Here minus 10 is there, so 2 and 2 kilo it will be divided. So V positive will be coming out to be minus 5 volt. Why minus 5 volt? Minus 10 came here. This is turned on. 2 and 2 kilo potential is divided, so this will be minus 5 volt. So V positive is coming out to be minus 5 volt, right? So another value of V in you are getting minus 5 volt. So this is your UTP and this is your LTP. What is your hysteresis width? 8 minus of 5, so that will be 13 volt. So this is your hysteresis width, this is your LTP, this is your UTP. Well and good. Very easy question. In these kind of questions, you should not be taking any time. You will be able to answer it very quickly. Even this question you will be able to answer very quickly. Here just I made the problem complex. In the examination you will see, okay, 7 volt will come here, then just find the potential equated to V in. But I just made it complex by this particular question. Otherwise it would be easy. What about this one? This is a good question. Just notice one thing there. Transfer characteristics you need to draw. Let me complete the question. For V0 versus V in. Okay. You need to draw the transfer characteristics for V0 versus V in. Not versus minus V in. So your actual input is V in here. Your actual input is V in. So V in is applied to some circuitry and then you got minus V in. How you can get minus V in from plus V in? This is how you can get minus V in from plus V in. This is resistance R, this is resistance R. Here you apply V in. So from here you got minus V in, right? Minus RF by R, negative feedback. So you can apply virtual short. So this minus V in is applied here. And then the circuit, then you need to tell about the nature of output. So you need to compare plus V in to V0. You need to make the characteristics between V0 and this V in, not between V0 and minus V in. Okay. So this is the question now. So what do you know? What kind of Schmitt trigger is this? If I forget about this minus V in, I just understand that this V in is some input. This V in is some VA input. Okay. If I assume this as a VA input, so for VA, this is a inverting Schmitt trigger, right? Inverting Schmitt trigger. Inverting Schmitt trigger. Say yes or no. So now what do we say? If your minus V, if your VA is high, then your V out will be low. This is the meaning of inverting Schmitt trigger. If VA is high, then V out will be low. What is VA? VA is minus V in. So if minus V in is high, what do you mean by minus V in is high? Can I say V in is low? If minus V in is high, that means if minus V in is high, what does that mean? That it is somewhat minus 5 volt. Minus 3 and minus 5. Which is higher? Minus 3 is higher, no? Minus V in is high. So V in will be low, no? Negative sign is there. So V in will be low. Right? If this is the higher, this is on the higher point, then if I remove the minus sign, then this will be on the lower side. But if I add the minus sign, then this will be on the higher side. So V in will be low. If VA is high, then V0 will be low. So what did you understand from here, from this particular analysis? First I consider if VA is high, then V0 will be low. That I know because it is a inverting Schmitt trigger. So if VA is high, that means minus V in is high because VA is equals to minus V. That means V in is low. So what did you understand from here? That if your V in is low, then your V0 is also low. And second conclusion will be what? That if my V in is high, then my V0 will also be high. So for minus V in, it was inverting Schmitt trigger, but for plus V in, it is becoming non-inverting Schmitt trigger. So by the circuitry it looks like that it is inverting Schmitt trigger, but actually it is non-inverting Schmitt trigger. Okay, so this works as non-inverting Schmitt trigger. Okay, what is our usual target? What is our V negative? Minus V in. What is our V positive? V positive is V naught into R1 upon R1 plus R2, right? So what do we do? First time we put a plus V set, second time we put a minus V set. So if I put a minus V set, then what will be the value I will be getting? V set into R1 upon R1 plus R2. So this will be my UTP. And here, if I put V naught equals to plus V set, then my V in will be minus V set upon R1 plus R2. So this will be my LTP. So now I can draw the characteristics as well. How will the characteristics look like? How will the characteristics look like? So here I am drawing the characteristics. I know that there will be this thing. For higher value you will get higher output. For lower value you will get lower output. Okay. Since it is non-inverting, that means non-inverting means anti-clockwise. Okay. You know this thing, you know here as well, whatever the potential are there. Now in the examination, you might not be confident with all this analysis that minus V in is high. You might not be get confident. So what you will do? You will do the whole analysis. I told you the whole analysis as well, no? Assume first I am at plus V set, or you can assume at minus V set as well. So first I am assuming myself to be at a plus V set. If I assume myself to be at plus V set, then I will find the potential of V positive. Then I will see when I will go towards V negative. Sorry, when I will go towards minus V set. So from plus V set, you are going towards minus V set. So whatever the condition is, based on that you draw the graph. Then assume your output to be minus V set. So from minus V set to plus V set, where I am going. You draw the transition point, and then from there you see how I need to go from minus V set to plus V set. So in that manner you draw the graph and then you get the characteristics. So I have also checked this particular analysis because I was also not confident with this analysis, right? In the examination it might happen that if this question is coming for the first time in your examination, you might not be confident with this analysis. So what you will do? You will do the exactly whole analysis that I taught you in the beginning of the lecture. So that analysis you can do very easily. Within 2 to 3 minutes, you will be able to do that and you will be able to make this characteristics. But if I am confident with this analysis, I don't even think I need to use the pen. Because what I will see, okay, minus V in. For minus V in, it is inverting. Then actually it will be non-inverting. Then in the options, this characteristic would be there. I will click on that. Right? But if I am not confident enough with the analysis, then I will do the whole analysis that I taught you earlier. Right? Let's see this one. So yeah, these kind of questions, I guess it would be coming into the examination in future. Till now, it not has been introduced. So here positive feedback is also there and negative feedback is also there. So shall I apply virtual short or it will be Schmitt trigger? So how I can comment on that? So the way of commenting here is that you need to see the nature of circuitry. In the first slide, right in the beginning, what did I tell you? In positive feedback, if I increase the output, then output will keep on increasing. And in negative feedback, if I increase the output, then eventually output will decrease. Then again it will increase, again it will decrease. And what did I tell you? Nullify the input source. Nullify the input source. Now, let's just say I increase the output by delta V naught. If I increase the output by delta V naught, so here this node will also increase, no? Because this will drive 0 ampere current and this will also drive 0 ampere current. So if this increases by delta V naught, so this will also increase by delta V naught by 2. So this node will also increase. But by how much it is increasing? Delta V naught by 2. Now this node will also increase. Right? This node will also increase. But by how much factor? Here what did I do? I applied the potential division R upon R plus R 1 by 2. Here also I will apply the potential division R upon R plus 3R. That will be 1 by 4. So this will increase by delta V naught by 4. Let's just say I would have increased my output by 1 volt. So here it would have increased by 1 by 2 factor and here it would have increased by 1 by 4 factor. So which potential is increasing more? This potential is increasing more. What is the output of V naught? What is the output of OpAmp? A into V positive minus V negative. So this guy is also increasing and this is also increasing. But this guy is increasing more. So output will increase more, right? This guy V positive is increasing more. So output will increase more. So eventually this is in positive feedback. Are you able to understand this point? So this is how we need to check. The like in conclusion, what we understood, that first we need to find the potential here. If I assume V naught here only, so I got to know that potential here is V naught by 2, and then here the potential will be V naught by 4. So who is having more factor? Which quantity is larger? This quantity is larger, so positive feedback is there. If this quantity came to be larger, then negative feedback would have been there. So conclusion is, just assume V naught there, here V naught by 4 will come, here V naught by 2 will come. So which quantity is larger? This is larger, so positive feedback is dominating. Why it is dominating? Did you understand the logic behind that? Okay, you understood, right? Yeah. So now there is positive feedback. That means it is Schmitt trigger. What kind of a Schmitt trigger is that? Input is connected to non-inverting side. If your input is connected to non-inverting side, what does that mean? If input is connected to non-inverting side, that is non-inverting Schmitt trigger. Non-inverting Schmitt trigger. Same thing I need to do. V positive, V negative. Those things I need to find. So what is my V negative this time? V naught by 4. Right? V negative is V naught by 4. This is your V naught. Here V naught by 4. This analysis is gone. Okay? This analysis is gone. But let's keep it here. But now, what is my target? I know that I need to find UTP LTP. So how do I find UTP LTP? Get V negative. V negative is V naught by 4. Get V positive now. What is V positive? V naught plus V in by 2. How did I write it? V naught into R plus V in into R divided by 2R. So this is my V positive. Next, what is the task? Assume plus V set and minus V set. So first what I am assuming? V naught to be plus V set. So what I will get? Plus V set by 4 divided by V set plus V in by 2. So V set equals to V set by 4 plus V set plus V in by 2. So 2 V set plus 2 V in. So V in is equals to minus V set by 2. Right? Did I do the calculation correctly? V set by 4, yeah. So this is one guy I am getting. Most probably it will be your LTP only. But let's check other value also we can check. So next we are going to put V naught equals to minus V set. So if I put minus V set, then what we are getting? Minus V set by 4 is equals to minus V set plus V in by 2. So 2 V set by 2. So yeah, V in equals to what we are getting? Plus V set by 2. So yeah, so here if I put plus V set by 2, so yeah, we are getting this the same thing. So this is your LTP, this is your UTP. Then you know how to draw the characteristics as well. Same thing, exactly the same thing. Plus V set minus V set, I know there will be one hysteresis. If there is hysteresis, then this is how I can draw the characteristics. I know for higher value it will give me higher output. For lower value it will give me lower output. Since it is non-inverting, so sorry, anti-clockwise. Really sorry. Yeah, anti-clockwise. This is how it will go. पहले वाले में मैंने clockwise बना दिया क्या? This goes anti-clockwise only, no? Anti-clockwise. यहाँ क्या बना रहा हूँ मैं? Oh, this I am making clockwise. Really sorry, really sorry. क्या कर रहा हूँ भाई मैं? Anti-clockwise. हाँ ठीक है. Okay. So anti-clockwise. Yeah, fine. In the previous one, did I mess up anywhere? This was also anti-clockwise. This was clockwise. Here I did not even draw the characteristics. Here I was expected to do the clockwise. Right? This was clockwise. Yeah. Did not mess up anywhere. Okay, so in these kind of analysis, you should have good amount of patience. Clockwise, anti-clockwise. This is anti-clockwise because this is converted to non-inverting it is. So anti-clockwise. Okay, my plus minus V set by 2 plus V set by 2. Plus V set by 2. All good? I guess this was the last question only. Okay. So yeah, we are done with the Schmitt trigger. So this was the first topic of our uh, positive feedback. Now other two topics are left, which are multivibrators. They are astable and monostable multivibrator. So now I have given you enough concept. So do I need to make the video on multivibrators as well? Because I think you have got enough concept. Now you can analyze multivibrator circuit on your own. So can you do that, or you want me to bring the video? I can bring the video if you guys require, but you need to comment down, because I guess now it should be enough that you can analyze multivibrators on your own. If you want me to bring, then I will bring. Otherwise, I guess it is fine. Okay, so you guys comment down, then I will see whether I need to bring it or not. And one more thing, for this video we are not bringing notes, because I told you the screen went off in between. Okay, first initial slides are like these slides are saved, but in between these slides are not saved. Like these are saved only. Then coming to this part, so half notes are saved, half are not saved. So, and build the habit without the notes as well. Okay, build the habit. Just watch the video, and what you will do now, seeing the notes and all these things, just see the video and proceed, right? This was just a revision video. So yeah, okay, thank you very much. You can comment down if you want the next video, I will bring. Thank you.